Welcome to this Skill Builder at a Glance tutorial on hypothesis testing in statistics. In statistics, a hypothesis is an assumption or a claim that we make about a new population parameter. For example, we might hypothesize that a new drug will improve reaction time. Then we test our hypothesis to find out whether it is valid or true. To do this, we gather evidence and use it to either support or reject our hypothesis. We have two types of hypothesis. First is a null hypothesis, which we can think of as the status quo, or the default assumption that we have before collecting the data. That is, there's no effect or no difference. So the new drug does not have an effect on reaction time, or there's no difference in reaction time. Second is the alternative hypothesis, which is what we want to prove. That is, that there is an effect or difference. So the new drug does have an effect on reaction time, or there is a difference in reaction time. To test these, we set a significance level, or alpha, which is typically set at 0.05. This defines how much risk of error we're willing to accept when deciding to reject the null hypothesis. To give an overview of the process of hypothesis testing, we formulate our hypotheses, set our significance level, then we calculate the p-value to assess the strength of the evidence against the null hypothesis. Based on that, we make a decision over whether to reject or accept the null hypothesis. If we reject the null hypothesis, we're saying that our data provides enough evidence to support the alternative hypothesis, and vice versa. So if we fail to reject the null hypothesis, we're saying that our data does not provide enough evidence to support the alternative hypothesis. We'll then report our results, presenting the findings clearly, including the conclusion and the implications of the hypothesis test. If we think back to our example, in order to conclude that our new drug significantly improves reaction time, the p-value that we've calculated would need to be the same as or less than the significance level. To quickly recap the key points, a hypothesis is a claim that we can make about something in a population, and we test it using data. We always start with the null hypothesis, which assumes that there's no effect or difference. The alternative hypothesis suggests the opposite, that there is an effect or difference. We use a significant level, usually set at 0.05, to decide whether the evidence is strong enough to reject the null hypothesis. So overall, hypothesis testing gives us a structured way to make decisions based on data rather than on guesswork. For further academic skills resources or to book an appointment with an SAS advisor, please go to kent.ac.uk/SAS or email us at sas@kent.ac.uk. Thank you.